This is factoring by grouping, part 2. Let's start with number 7. I'm going to write down the prime factorization of the numbers right above so that you can see it. Now let's get started. I noticed that number-wise, they don't have anything in common all the way across, and they don't all have x's and y's, so this actually doesn't have a greatest common factor, so I'm going to go ahead and group it. And again, how do we know that we're going to use grouping? We see that there are 4 terms. I'm going to put the first 2 terms together and the second 2 terms together. After I do that, I notice that the first 2 terms have a 5 in common and an x. When I factor the 5x out of the first term, I'm still going to be left with a 7y. When I factor the 5x out of the second term, I'm going to be left with a negative 1. Now bring down the sign between the 2 groups. 56 and 8 both have 3 2's in common, or an 8. When I factor the negative 8 out of the first term, I'm going to be left with the 7y. When I factor the negative 8 out of the second term, I'm going to be left with a negative 1. Now, it's not an accident that the 2 terms you end up with have a common parentheses. If you don't have a matching parentheses, something's wrong. And you can go back and multiply through back again to check and make sure you can fix the signs then. Excuse me. Now, once I have 2 terms, I'm going to factor out their greatest common factor, which will always be that parentheses that matches. When I factor the 7y minus 1 out of the first parentheses, I'm left with 5x. When I factor the 7y minus 1 out of the second parentheses, we're left with minus 8. Let's look at number 9. I don't have constants in all of it, but I do know that 5 and 25 have factors made of 5's. Because the first term doesn't have any 5's in it, I know that it doesn't have a constant in common all the way across. Then I'm looking and I don't see m's or z's in all of the terms, so I'm going to go ahead and say that there is no greatest common factor. So I'll group it. And again, I know to group because there are 4 pieces. The first 2 pieces have an m in common. When I factor it out of the first term, it's going to leave behind a z. When I factor it out of the second term, I'm going to be left with a minus 5h squared. Bring down the sign between the 2 factors, or the 2 groups. The group has a 5 in common all the way across and an n. When I factor the negative 5 in out of the first term, it's going to leave behind a z. When I factor the negative 5 in out of the second term, it's going to leave behind a minus 5 and an h squared. Now I'm down to 2 terms. These 2 terms happen to have that factor of z minus 5h squared in common. I can open up my leftover parentheses. When I factor the z minus 5h squared out of the first term, I'm left with an m. When I factor the z minus 5h squared out of the second term, I'm left with a minus 5n. Remember, you can always check by multiplying all the way back through again. If you get back to the original, even if they're out of order a little bit, you've got the right answer. Let's continue. Now on this one, I'm going to ask you to put a star by it. Because it will actually be a 2-part question in that 40, 30, 100, and 75 will all have a common factor first. Now 40 factors into 2 times 2 times 2 times 5. 30 is 2 times 3 times 5. 100 is 2 times 2 times 5 times 5. And 75 is 3 times 5 times 5. Once you have all the prime factorization of the numbers built, you notice that they all have 1 5 in common. So it actually had a greatest common factor. That is always to your advantage to see ahead of time because that will make the numbers that are left that much smaller. In fact, if you factor the 5 out of the first term, you're going to be left with an 8xy. If you factor the 5 out of the second term, you're going to be left with a positive 6x. If you factor it out of the third term, it's going to leave behind a minus 20y. And if you factor it out of the last term, you get a minus 15. But notice, after taking out the greatest common factor, we still have 4 terms. So we now have to do our greatest factoring by grouping. Now, what do you do with the 5? Well, he's going to be part of our final answer. But first, let's do grouping. If you look at the 8 and the 6, the factors we have already built. We had taken the 5 out, which left 8 as 2 times 2 times 2. We took the 5 out of 30, which left that as 2 times 3. In other words, you can just come back up here to the top, and you don't have to refactor everything. Kind of nice. Now, the first 2 pieces have a 2 in common all the way across. So I'm going to factor the 2 out. When I factor 2, and an x, it looks like, when you factor a 2 and an x out of the first group, it's going to leave behind a 4y plus, when I factor the 2x out of the second term, it's going to leave behind a 3. Bring down the negative between the 2 groups. 20y and 15 both have a 5 in common. I'm going to factor that out. When I factor the negative 5 out of negative 20y, it's going to leave behind a 4y. When I factor the negative 5 out of the second term, it's going to leave behind a positive 3. Now we're almost finished. We have the 4-term phrase down to 2 terms. Those 2 terms have a greatest common factor of 4y plus 3. Open up the leftover parentheses. When you factor the 4y plus 3 out of the first term, it's going to leave behind a 2x. When you factor the 4y plus 3 out of the second term, it's going to leave behind a negative 5. And don't forget, that 5 that you took out at the very beginning, he comes down. He is part of your final answer. I'll see you in the last video for the last 2 examples.